I want to very briefly talk about analog to digital conversion in this video, and I want to talk about what are the steps that are involved in converting an analog signal into a digital signal. So this slide kind of summarizes what is involved in converting an analog signal into a digital signal. So we have already discussed in the previous videos and in Medical Instrumentation 1 the fact that uh, to convert an analog signal into a digital signal, we want to do at least two things. One is we want to quantize the time domain. So we want to take samples at certain time instance and not at all time instance. And that process is called sampling. And secondly, what we want to do is we want to quantize the amplitude axis, which means that we don't want all values of amplitude, but we only want certain values of amplitude. And that is called quantization. So that is what is shown in this slide. So you have an analog signal here, say. The first thing you want to do as you're converting your uh, analog signal into a digital signal would be to sample the signal. And this is done by a circuit that could be called a sampler, or it could also be called sample and hold circuits. And we'll look at it in detail in the next few videos. So what does a sampler do? What a sampler does is it takes this analog signal, which is defined at all instants of time, and just defines it at certain moments of time. We don't care about the values between this time and this time, right? Okay, now so this signal is called a discrete time signal. So the analog signal is a continuous time signal. The time is defined at all moments of time. But a discrete time signal is only defined at discrete time instance. Once we do that, what we want to do is we want to then quantize the signal. This is called the quantizer. And this is done by a system called a quantizer. And what a quantizer does is it takes the amplitude and instead of having an infinite number of amplitude values, it says, okay, I want to approximate my signal with just some fixed values of amplitude. Okay, and that's what is shown in the signal here. So you can see that these 3 points here are three different analog values, but they are all mapped to the same quantized value at here. So what we get, the signal that we get here is a discrete time signal, but it is also quantized in amplitude. Okay. Once you do that, you want another circuit called the coder, which actually codes each of these amplitude values in terms of a digital number. And by a digital number, we mean a number that is specified only by zeros and ones, right? It's a binary number. So, so this signal then is a digital signal. So we have moved from an analog signal to a digital signal. And there are three steps involved in the conversion. There is sampling, there is quantization, and there is coding.